Glad to be here. How's everybody feeling today? Yeah? Awesome. Well, there's been a lot of themes discussed today, from KPIs to artificial intelligence to even fear, uncertainty, and doubt. Just wanted to start this talk. This is something that I've been wanting to talk about for, honestly, almost 2 decades, but it finally started to put this together last year. So one of the key things is we're understanding not only where we started, but the path of where we're going. And there's a lot of pieces and parts in moving to this, and it's very especially important for those that are here in OT. So the purpose of this talk is for those that are new to our industry, new to security, but also for the folks that are older, like myself, that have been around for the ride, right, as we've adopted these new digital technologies. So the key piece here is, what is normalization of deviance? Normalization of deviance is a phenomenon by which groups, individuals, organizations come to accept a lower performance of standard until that standard becomes the new normal. So we've seen this. We've seen this maybe over the last 3 decades with vehicles. You know, you've had a physical key switch, went to the column, went into the car, you turned it from the ignition, goes through the actual electromechanical relay, goes to the starter, starts the vehicle. In today's world, you get into your car, hopefully you have your key fob, you now are requesting the vehicle to start as a digital input. You're requesting ABS to either be enabled or be disabled. And so these are the things that we're dealing with today in this world that we go through. So another key factor that we have to keep in mind is that this is not changing. We've went from where we were to where we're going today to tomorrow. A lot of my talk today is going to be around the work of Dr. Diane Vaughan. She was key and pivotal in the writing a book on the Challenger disaster, which happened in 1986. I was 15 years old, happened January 28th, where 7 astronauts lost their lives. One of the key things here is that she defines this as a process where a clearly unsafe practice comes to be considered normal if it doesn't immediately cause a catastrophe. Now, having worked in a petrochemical facility for almost 2 decades, we worked around a lot of hazardous materials. You say that it definitely will leave a punch. It won't leave you standing with some of the chemicals that we used. And one of the saving graces was our safety systems. Of course, our policies, our engineering, our MOCs. But one key factor here that Dr. Diane has been able to study, especially with what happened with NASA not once, twice, and even the effects of the BP Texas City, for example, is that this long dwell time, this long incubation period where early warning signs are either misinterpreted, missed, or neglected, or just completely ignored. And so that's the fundamental piece that we're dealing with, is understanding where in our process with our companies, our organizations, our technicians, our maintenance staff, our vendors, our integrators, all this piece of it, we need to be able to stand where that is. So how did we get here? So Dr. David Clark mentioned that he thought there might be 10,000 computers or machines or devices connected to the internet. And if you now scale your own block within your community, you well have over 10,000 devices. And the amount of systems that I've seen and I've assessed in my 20 years of doing risk assessments and field walks and surveys and helping folks, and not only as an asset owner, but also as a consultant, I can tell you that there are a lot of things that have gotten us here. Some key pieces that are very important to know is that I was trained by some of the best mentors in the world. I'm very fortunate. The woman who actually gave and took me under her wing taught me how to design around failure, design around bugs, design around bugs in control systems, bugs in safety systems, and yes, systems do have bugs. One of the key elements of also how we got here is knowing that it took time. So having worked at a plant that was built in the 40s, I got to work on and cut my teeth on industrial control systems that were pneumatic. So what you're looking at here, these are my pictures, is our pneumatic computers. These are Foxborough pneumatic computers, pneumatic chart recorders, and there are about 8 devices here that are powered with 120 volt power, and those are just chart recorders. So basic process control was pneumatics, emergency shutdown was electromechanical shutdowns. A lot different than where we're at today. Here's a heater train on an LNG facility here in the US. Now this is a few years old, but in this, these are the credentials that were on the machine at the time, and also had interconnects and remote desktop and all the other neat things that a safety system shouldn't have, but yet it did. And now we walk into the new control systems or the operator control rooms of today, where a single operator could be running 4 units at a time while starting up another unit and be able to control the facility and also have remote access from the vendor or the integrator, or even troubleshoot possibly from their mobile phone. So, walking through how we got here, because this is very important, especially on that long incubation time, as we started to accept systems coming in that were digitized. So we went from pneumatics or electromechanical relays, and we started to use safety PLCs to help improve our safety and reliability. We had 2 out of 3 voting, so TMR, triple modular redundant to enhance safety and availability, TUV certified, so these met stringent German standards, and we were dealing with serial, proprietary, high-level, low-level bus communications. Examples of this, Triconics, Tricon, ICS Triplex Regent, and the one that was actually the pioneer of triple modular redundancy was August Systems, and that was at the cusp of going into the 80s. Triconics was the third to actually develop the TMR, but August Systems was the premier. So we went from pneumatics in this original normal, so focus on this deviation spiral, because this is going to be tying into Dr. Diane Vaughn's very important discussion. So we went from pneumatics, electromechanical, to starting to deviate. And so we created this in the 80s to where we're using electronic systems and electronic devices to do our control, but also our safety. And since we didn't have any immediate failure, keep thinking of Dr. Diane Vaughn, this started to become our new normal. Long dwell times. So then we get into the 1990s. And as we moved to the 90s, we started looking at actually getting diagnostics, even enhanced capabilities. TUV certified, 1 out of 2 voting, or dual modulant redundant. Safety and availability, and here's a key thing, because we are human, we want it cheaper, faster, better, and more reliable. That's the cusp. That's the things that we're looking for. And also, this is when 61508 became standardized, and this is also when us asset owners asked the vendors to start using Windows or bring Windows into our environment, because we needed something that we could actually commercial off the shelf work with. And so began the spiral of, when you call tech support, they say, have you tried rebooting, right? That's usually the first thing that folks say. But here's the thing, is that it had improved integration to the distributed control systems or PLC, so that was being led by folks like Moore, Quadlog, Apex, which is now Siemens, the HEMA, the High Quad. I actually trained on all these systems. Been able to work with HEMA as well, and then the ABB Master Safeguard. So again, asset owners requested, not the vendors. I hear a lot of people say, it's the vendors, they brought this problem on us. No, that's not true. The fact of the matter is, we asked for it. So this new deviation allowed us to be able to communicate at a lower level, so we had 2 engineering workstations and be able to communicate across and pack arrays and be able to send statuses over to the DCS. All in well, all is good, no major critical failures. So then we said, hey, this is our new normal, let's now move on. So this second deviation allowed us to say, hey, this is working out pretty well for us, we're saving money, and we haven't had any immediate failures. Now, again, at this time, we were designing around failure around bugs in code, bugs in the systems. You know, when you see a standby controller on your safety system being pulled by the vendor, and it should stay on primary, and they pull that card out, the secondary card, and the whole plant goes down, those are the types of bugs that I'm talking about, that reliance and that reliability. So then we get into the 2000s. This is where things start to really, really scale and tie together. We started to employ even higher diagnostics to achieve higher safety, much modularity so we could pop out cards, put things in. We were still certified to IEC 61508, and they all offered, most vendors all offered the tight integration respective DCS systems known as integrated control and safety. So field buses, same thing. Siemens, Emerson Delta V SIS, Yokogawa ProSafe, those are just to name a few. Again, tighter integration, moving through. These are decades where we've taken this idea and started moving the ball. So now we've got a common engineering station, we've got common operator stations, and now we have, for ease of sake and convenience, we have one database to manage, one set of graphics to handle. So this is all really well and good. And so this is, we no longer needed to pack data arrays to send across serially or through TwinAx or anything at the lower level communication stack. We can now do it at the top level CPU to CPU. But this is where cybersecurity started to become very interesting. So here we are 3 decades later, deviation, we've accepted digital systems, and now we've got this new normal. However, now we started to actually have incidents. So Olympic Games, everybody knows about Olympic Games and the Natanz facility and the centrifuges. There are other things, for example, Telvent also was an issue where a lot of the blueprints for many asset owners like myself were exposed. Other incidents like Dragonfly, I was told earlier not to mention the Marucci Shire, so I won't. But the idea here is, so the point is that we've migrated and now we're starting to see, as this connectivity, we've had, as Dr. Diane Vaughn said, these clear early warning indicators that we've either neglected, omitted, or just said, nothing bad's really happened, so hey, you know, let's just continue with the pace. I took the DHS Idaho National Labs training for the chemical sector in 2009, okay? Not 2019, 2009. And I can tell you there's a lot of folks that are in here that started securing their systems at a very, very early stage. And so when Dale talks about KPIs and maybe we shouldn't have fear, uncertainty, and doubt, the fact of the matter, the true KPI are the warriors like yourselves that are actually carrying and going out, learning, doing separation, managing your systems, doing defense in depth strategies, whether it's SANS or standards-based. That's the true KPI. So focus on the actual graphic here. So for those that are new, because I did say that I'm going to be talking about new things, is that we try to keep our process in check. So our basic process control, we try to manage that. If it starts to go out of control, we start to get alarming. We get actual operator input, intervention, and lo and behold, if for any reasons the operator can't get the process into a safe state, our emergency shutdown systems or our safety instrumented systems or safety critical systems will kick in. If they do not, then we now get up into where our passive and active safeguards are in place, such as rupture discs, relief valves. Now, if you look over on the right-hand side on the spiral, and again, thinking of Dr. Diane Vaughn, we've had a lot of time to start thinking about how we've digitized and how we've adopted. So at this point, this is where we should really be thinking, okay, let's pull back a little bit, right? So tying that in. So let's talk about one thing. In 1987 was the very first paper anybody ever spoke about, at least for the process industries, about programmable electronic devices for safety applications, 1987. So we've already started to spiral. And then in 1993, the American Institute of Chemical Engineers and the Congress on Process Safety issued guidelines for automation in chemical processes. About 50 pages were just on interlocks and how to design interlocks and fail-safes. Again, a guideline, not a standard. So, and then in 1996, several years later, we had the ISA 84, S84 Committee for Applications of Safety Instrumented Systems. My point here is that we're still not even talking about cybersecurity. We're talking about bugs and reliability. And as we move further, we get into 61508, which came out in 1998 to 2000. It had several parts, multiple parts involved. And then in 2003, 61511 for functional safety came of age. So that right at that post-Y2K era. And this is all very important for this talk because as we have grown and moved forward, we didn't start seeing standards on the stuff we were implementing until decades later. So as you can see, there was a rewrite in 2010, and then in 2016 was the very first time any of the standards bodies came together and actually looked at this and said, hey, if you have a safety instrumented system, we're going to put in cyber clauses now that say you shall do a risk assessment. They didn't tell you how to do the risk assessment. They just said you shall do one. So very important. Now they did point to 62443, but it left it up to the asset owner to make that decision. 2017, the TR84 committee put out the cybersecurity related to functional safety. And then in 2019, the National Fire Protection Agency for boiler, large-scale combustible systems and boilers and fire and gas systems came out and said now you can actually put in safety and process control on the same backplane. We allow it. You don't need watchdog timers anymore. And then what I want to do is a compare and contrast here to show you where we've also went from the cyber side. So ISA 99 was built in 2002, put together. 2007 was the very first standard on terminology, concepts, and models. 2007, all right? 2013, that's when the 3-3 standard came out, and that is the very first year that 882 came out. So NIST was still steadily building things and putting things in, and then 2013 was that first piece. 2014, I'm sure everybody, as you know, the NIST cybersecurity framework came out, also fairly late to the game. 2015, 882, Rev 2, 2-4 came out in 2018, all the way through. And then in 2020, the first standard for risk assessing industrial automation and control systems came out. And John Cusimano and Jim Gilson were the chairs for that, and you should talk to them. It took 7 years to make that standard come to fruition. So standards take a very long time. And then in 2023, the 800-82 came out. So again, thinking about that deviation spiral, we've accepted this as humans, the sociological pieces and the impacts, and this long incubation period, and then we're just trying to sticker stamp and fix things at the tail end after we've already went through full adoption. So this is our new norm. This is our new deviation of normal, right? Is everyone needs that data, whether it's coming from the safety system, whether it's coming from the BPCS. They need it now. Don't care, all of it, gotta have it. I need KPI data sent to my cell phone. For example, I need to connect it, right? That's the IT mantra, is you have to connect it for us to protect it. And so we've got to monitor it to our SOC. And here's the big one, right? Can I remote troubleshoot from the hotel? Anywhere in the world, could be anywhere, possibly at another hacker conference. And the reality of this is that we've accepted this. This has become our new normal. And I'm not saying it's not, or you're bad for doing it. I'm sure that there's ways and mechanisms you can do it, but I'm just trying to point out to you that deviation spiral of where we're at. So this brings us into the now. So 4 decades later, we are now looking at our new normal, and we've seen Triton, right? That was the first malware to actually infect a safety instrumented system. We've had other near misses or near accidents as well, some that can be discussed, some that cannot be discussed. And then COVID was a major game changer in the fact that we had non-traditional users now requesting to get access to the safety instrumented systems, requesting to be able to remote troubleshoot so they didn't infect their other human beings. So there was a lot of emergency MOCs that were put in place. There was a lot of things that in our industry that are temporary that become permanent. And so we've already went down that spiral to where once we allow it, it's hard to pull that back. So keep that in mind as you're running through it. So what is the next thing, right? So Volt Typhoon, Rob's been talking on the Hill for many years now about what keeps him up at night and conveying that to our leaders up in D.C. Port of Houston, a near miss there as well, just here in 2020, 2021, and another port here recently as well. So the point of the talk is to drive your awareness, to drive it because I don't own your risk, you do. You own your risk. And so we've gotten out of the repercussions or the quest to be able to say, yes, but why? And understanding that especially if it's safety critical, we need to be able to know what you're doing when you're putting these things in place and try to have that independence. Right? Makes sense. Makes sense. So here's the thing of my talk, is that we all need to collaborate. We need to work together. I agree, the fear, uncertainty, and doubt, but you have to keep in mind there's a lot of warriors and heroes in here that do this on a day-to-day basis that have been securing their manufacturing sites and system sites. And thankfully, we have a platform such as S4 and many others to be able to come here and collaborate and see what the others are doing. That's really the best part of a show right here. So embrace this bright future, work together, cultivate this growth, learn from past deviations. Think of Dr. Diane Vaughn when she talks about how we normalize and we need to start questioning things well in advance before there is a catastrophe. And together we can celebrate the power of continuous improvement, forging a path towards safer, more innovative, and extraordinary achievements. And the future is up to you, believe. Thank you. Thank you.